Let's use Excel to do a comparison between linear and exponential models. So we can do this by hand using a calculator, and that's great. But we're going to do an expanse 12 months, looking at how accounts can grow differently depending whether they're using linear exponential growth, and then we're going to graph that. So first off, we have each account begins with $10,000. For our linear model, we're going to have that increase by $500 per month. And for exponential, we're going to increase 5% per month. So remember that with linear modeling, we have a constant numeric change each time period. And with exponential, we have a percentage increase per time period. All right, so first let's write models. So for the linear model, if we think about a linear model, it's y equals mx plus b, right? That's our general linear model. So what do we know? Well, we know that slope m is the constant change. In this case, that's our increase per month. So we are going to increase $500 for every month. I'm going to use x as my months. And then we're going to add the y-intercept, which is our starting point. So 500x plus 1,000. So there is our model for our linear. Now for exponential, that's going to be just a little different. We know that exponential is y equals. We're going to have our starting amount. I'm going to call that p. Then inside we have an increase. So 1 plus the percent increase. And that's raised to the time period. And again, I'll use x as our time period. So when we're putting this in, I know that my initial amount is 10,000. And then I have 1 plus, I change, oops, forgot the plus sign, change my percent to a decimal, and then I raise to the number of months. All right, now that we have our general models, we can put that over in our table. So for the linear model, now cell B2 is going to represent the amount in month 0. So we know in our equation, y is the ending amount. So I'm just going to start with equals 500 times the month, right? X is the number of months. So I'm going to use my cell reference for A2, and then I'm going to add 10,000. So again, because I'm using a formula, I start with the equal sign. I use the little snowflake, if you will, as multiplication, and I'm using the cell reference. Now, when I hit this, it gives me 10,000, and that's how it should be because it's month 0. That's our starting point. Because we used a cell reference of A2, I can use my autofill. So if I go into the bottom right corner where that green square is and go so that it gives me a black plus sign, I can just double click on that and it will autofill. So for month 1 here in cell B3, when I click on that, you can see up here in the bar that it gives me 500 times A3, because we are now in month 1 plus 10,000. So for every one of these, because the cell reference, it just changes to be the new cell reference, which updates. So you can see the amount in our account for each month when we have a $500 per month increase. Now let's move on to exponential. Again, I start with equals because of the formula. We're going to start with 10,000. Now I know in mathematics, we know that a number touching a parentheses means multiply, but Excel doesn't know that. You have to tell it to multiply. So I'm going to use again the snowflake, and then in parentheses, I'm going to use my 1.05. I just added the 1 plus the 0.05 over here. Oop. Right, so the 1 plus 0.05 inside, I just put those together to get the 1.05. And then I'm going to raise that to the number of months. So again, we're going to use the cell reference to represent the number of months. And again, my starting value is 10,000, so that makes sense. Again, because we're using cell references, we can autofill. So I put the parenthesis or the cursor over that green box, so it gives me the black plus sign, and then I autofill. So again, you can see if you click on all of these, the exponent changes to the new cell reference. And now we can compare month to month. You'll notice initially they're the same. The first month is the same because 5% of 10,000 is 500. But after that is when the values change. Now we can compare pretty easily. We can see very quickly that the exponential model yields more over time. But if I highlight all three of these columns, month, linear, and exponential, and then I'm going to go up to insert, and I'm just going to hit recommended charts. So you can see that it gives us kind of a couple of different options, and I'm going to use this line graph here. So this line graph, and I'll make it bigger so we can look at it. It gives me months 1 through 12, and you can see that the linear is blue, which makes sense because it is just a straight line, and the exponential has got a little bit of a curve to it. The larger the percentage of increase, the more steep that, or the steeper that curve would be. So 5% is pretty small percent, so it's going to be a pretty small curve. But we can see that, like, month 1 and 2, months 0, 1, and 2, there's really no differentiator between the two lines. But when we get to month 3, you can start to see that the orange line is above the blue. And then as we move to the right, we get more separation. And this would just continue. If we would continue these out, so let's go ahead over here just for fun. I highlight these to show the pattern, and then I'm just going to drag to bring this out a couple more months. I can use the autofill. It'll continue with the pattern. And then if I redo my graph to take into account these extra months, this is all I'm doing is just doing a little comparison here. So you can see if we bring it out even more months, the last one we stopped at 12. So you can see where 12 is here. And it's got a little bit of a distance between the orange and blue line. But if you go all the way out to month 23, you can just see how it continues to widen. And that is because over time, your linear model is simply still growing at $500 a month. But the exponential, because the 5% is based off the previous month, that means we are constantly adding more than 500. So every month it's just a little bit more, and that's why we get wider and wider separation between the linear and the exponential. So that's just one way you can use Excel to create linear exponential models and to compare them using a graph.